Okay, number 35. Describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function, which is 1 over x. So originally it started out as 1 over x, and we did some stuff to the function. We've got a negative 3 over x plus 5. And so what are those things that we've done to the function? What do they do to the graph of it? I can kind of take this negative 3 over x plus 5 and take the negative 3 out, factor it out, and say negative 3 times 1 over x plus 5. And then I'm going to follow kind of the order of operations. I always do stuff that's in parentheses first, so I'm going to do what happened to the x first. So the first thing here is that we added 5 to x. Anytime we have a change in x, it's some kind of horizontal change. And for this one, adding 5 means to shift left 5 units. And then we multiplied by 3. And we multiplied actually the whole function by 3. So anytime you multiply the whole function, that's going to be a vertical change, and it's a vertical, in this case it's stretch because 3 is greater than 1. If it were less than 1, it would be a shrink. And then the final thing is that negative on the entire function, and so it's changing the y, which means we reflect across the x-axis to get a change in y. And so that's going to be B. Shift left 5 units, reflect across the x-axis, and stretch by a factor of 3. For number 36, you want to evaluate the log function. In order to do that, evaluate just means get the answer. We're going to change that to an exponential function. No, I'm sorry, we're not going to change this one to an exponential function. We're just going to try to use our properties of logs to get our answer. So we've got log base 9. What I would like to do is take this 1 over 81 and see how it relates to 9. Log base 9 of 1 over 81 could be written as 1 over 9 squared, because 9 squared is 81. And I don't really want a fraction there, so I'm going to write that, change the exponent a little bit, and write this as log base 9 of 9 to the negative second. Since we have the same base here as this, then our answer is actually going to be the negative 2. So my answer is negative 2, which is the same as our exponent there. And so the answer is D. Number 37 says find the exponential function that satisfies the given conditions. So an exponential function is a function that has an exponent that is a variable. In this case, we are given a percentage here. So, and it says it's an initial mass of 23 grams and a decrease at a rate of 3% per day. This is kind of like the exponential function, but in the form of the population function. P of t equals initial population, which in this case is actually going to be our initial mass. And since we have a percentage, we would have 1 plus r times t, r being the rate, and we add a 1 since it's a percent there. So my initial mass was 23. Now the rate, it's a decrease. The rate is, because it's a decrease, we're going to say that's a negative, and negative 3% would be 0.03. So that would be the rate. So plus a rate of negative 0.03 to the t. And then we would just simplify that. 23, 1 plus negative 0.03 is 0.97 t. So that would be our function. Now they didn't use p of t, they used m of t, but the answer would be B. Okay, for number 38, we have a word problem. It says a satellite camera takes a rectangular shaped picture. The smallest region that can be photographed is a 4 kilometer by 6 kilometer rectangle. As the camera zooms out, the length L and the width W of the rectangle increase at a rate of 3 kilometers per second. So the increase is the same for both length and width. How long does it take for the area to be at least 4 times its original size? So we started out, we have a rectangle, and we're going to start it out at the smallest side. That's 4 kilometers by 6 kilometers is what it starts out as. And then as you zoom out with your camera, it progressively gets larger, both the length and the width. And the width is increased by 3 kilometers every second. So depending on the number of seconds, you know, if it was 1 second, it would just be by 3. 2 seconds, it's going to be double that, which is by 6. So we're going to multiply that by time. And then we have the length, which is also 6 plus 3t, because for every second we increase it by 3 more kilometers. We want to know how long, so the time it takes, when the area is at least 4 times its original size. The original size is 6 by 4, which is 24 kilometers. That's the original area. So we're kind of looking at the area of this one, and it just depending on how much we zoom out, that area is going to change. So the new area would be length times width as well, but it would be 6 plus 3t times 4 plus 3t. And we want to know when that area is at least 4 times its original size. So greater than or equal to 4 times the original size, which was 24. I'm going to simplify that inequality. I'm going to do the FOIL method, so that's 24 plus 18t plus 12t plus 9t squared is greater than or equal to 96. And then I'm going to bring everything over to the the left side and simplify. So that now I have 9t squared plus 30t, and then I've got 24. I'm going to subtract 96, so that would be minus 72 is greater than or equal to 0. Once I get my function, then I'm going to graph that and tell when my function itself is greater than or equal to 0. So when is the function greater than or equal to 0? Okay, so I've put the function in my graphing calculator, and I put it in as an equality. I'm going to zoom out, and I want to know, actually I want to be able to see the whole thing. I'm really only concerned where y is greater than 0. So where does that happen at? I'm going to change my window a little bit here, just so we can see our x values better. Now, y is greater than 0 when x, which is our time here in this case, is negative 4.95, but we can't have negative time. So we go to the other point of intersection here where y is greater than 0, and we see that we have 1.62 is our time. So that would be our answer for the function, 1.62 seconds, or 62 seconds. All right, number 39, it says determine if the function is a power function. If it is, state the power and the constant of variation. So for this one, it is a power function. A power function can have a constant, and then it has a variable, and on that variable it has an exponent, which we do. And so my constant of variation would be the number that's multiplied by x, that's 3, and my exponent, or my power, would be 1/7. So the answer would be C there. All right, so for number 40, we want to find the domain of the function. For this, all I would do is graph it and look at what your x values are. I'd also look at my multiple choice answers and see if, is it negative infinity to infinity, or is 1 or -1 somehow play a part, or have no value there, or is not a solution. So let's graph it and see what happens. All right, so I've graphed the function, and I'm going to just zoom out to see what happens here. It looks like something's going on here at -1, and the question is that a solution or not? So for this one, I'm going to zoom back out here. So for this one, it looks like something's happening at -1, just by looking at the graph. So you might test -1 in the function. If I put -1 in there,